All right, NAE4, the zigzag tank. This is my design concept. Let's get into it. A little bit of background on hydroponics. Hydroponics is a method of hydroculture. We can use a specific structure and solution to cultivate a specific plant to maximize the CO2 consumption and oxygen production. Hydroponic systems refrain from using soil and focus on solution-driven growth. The solution is pumped to the top where it then flows down while the plants absorb it. The solution carries the required nutrients the plants need to grow. Design criteria, we came up with 5 solution parameters. For safety, we wanted to meet the safety requirements and follow the engineering code of ethics. For the low energy input, we want to keep emissions low and use solar power. For the low cost, we want long-term low cost performance. For carbon negative, we want to reduce the carbon levels in the atmosphere. And for scalability/implementability, we want to be able to implement this idea into other parts of society and infrastructure. So some design features, as you can see, this is the product that I am recommending. We have a reservoir at the bottom with solution. A water pump running off of solar energy will then pump the water to the top of this zigzag structure where it will flow down naturally because of the incline. As it does that, plants will consume the nutrients and take in the nutrients that they need, right? CO2 will go into the plants and oxygen will be expelled. Some of the features are its vertical zigzag structure, its overall pleasing aesthetic, its implementability, and size. So how do we address the problem? Essentially, like I said, the plants will consume any CO2 that is in the environment, in the enclosed system, and release oxygen. We will pump the building's CO2 into the tanks, right? This will be an enclosed system that we can put in between walls, as you'll see in the next slide, that will allow us to reduce the levels of CO2. The plant of choice is the Tulsi, as it is a very good plant to consume CO2 and expel oxygen, obviously, right? Next slide. We want to look at implementability and versatility, right? So my design will be able to put between the windows of the exterior walls of the building, right? Not only would this be compact and very environmentally friendly, but it is how we will reduce the levels of CO2. So finally, the design evaluation. When we evaluate it, we get a total pointage of 283 points. It lacks in areas like the cost and the energy input because solar power is not cheap, and solar power is what we're using in this case to power the pump, right? Safety, overall, it's a 10 out of 10. Carbon negative, we get a 7 out of 8 because I believe it will be very effective. And scalability, 8 out of 8 because as we saw, we can put this in between the walls of the buildings, right? Not only would this be effective, but easy to work with. So yes.